Wee, kaleidoscope. All right, not bad. I'm doing okay. I hope everybody out there is doing okay. All right, today's going to be a relatively straightforward one. Sorry, a cat suddenly came peeking around the corner. Hold on, you guys want to see? Oh, you really can't see him. It's too dark, and now he's licking his butt. So we're going to come back over here. All right, so today's going to be a relatively short one. Today, I basically just want to check your work, make sure that everybody is more or less on the same page. And then starting next week, we're going to be working on review towards testing out on evolution. I'm thinking like Thursday. That seems reasonable. So, starting that off, did everybody do okay with the practice questions that you guys had last night? Number one was about the newts. Number two with the peaches. Number three was Venus flytraps. Yeah. Number five was a bit of a beast. But, that's how these things normally work, right? The nice thing is, I don't think you need to worry about number five or a question like that quite so much on the AP exam. With the elimination of the math component, I think it's unlikely that they are going to ask you something that level of math intense. It's possible that it might drop as one of the free response questions, but usually the free response questions don't have that much math. The free response are more across the board. They want to see, can you take all these different subjects and bring them together? All right, well, why don't we check? We can just check on the first few because I did not provide you guys with an answer key. So, for number one, looking at our newts. How do I need to orient this? For A, B, and C, you should have come up with values that were relatively close to this. I'm sure everybody did fine on 1A, given that they gave you the numbers and it was very simple math. Part 1B, some people get confused because they go for those frequencies instead of multiplying them by the total population size to find out what the actual expected value would be. And then 1C, I apologize, there was a typo in that. It should be if they're not in alignment, then what might be responsible. But I believe the question worded it really weirdly by saying, are they in alignment? And then if they are, what's wrong with them? Which doesn't make any sense at all. Number one look pretty good. Excellent. All right, number two, looking at our peaches. So now they gave us the total population size, 500. They gave us just straight away the Q value. So it's really quick to figure out what the P value was. Then we just have to calculate out which ones, sorry, let me slow down. How many of each we would expect to see. Now it's important to note here, remember, your p squared and your 2pq, these two values have to be added together because they're both going to produce a dominant phenotype. And if you looked at the question, they didn't give you the amount of heterozygous, they just gave you the amount of the dominant. I believe dominant was bald, and the fuzzy peach was the recessive. Then we have to go through our chi-square analysis. Observed minus the expected, squared divided by the expected. These numbers tell us we expect 255. And by the time you got here, I'm hoping most of you had a pretty good idea whether or not you were going to be accepting or refusing the null hypothesis. First of all, how many degrees of freedom did you have to look on your chart? We have two different possibilities here. So how many degrees of freedom did you have? Correct. You should have only had one. And if we take a look at your chart on the reference tables at 0.05, correct, Mikey, that would be a critical value of 3.84. So when we add this total together, you should have gotten one that was it above or below our critical value of 3.84. And it was below. So what do we do with the null hypothesis? Do we accept or refuse? Correct. If it's below the critical value, we accept the null hypothesis. We accept that statistically, there's no difference in the numbers that we got from the numbers that were expected. All right, now, whiteboard space is at a premium, so I only wrote up these two. But we can go over the other ones, and if anybody wants a step-by-step, I'll help you out. It sounds like a lot of people would like to see a step-by-step of number 5. You guys want to see something else that's fun? Over here. Alice, look at the camera. This is the puppy dog that decided to get sprayed by the skunk. And now she's right here. Take a wild guess what it smells like. Alright. Now, while I erase this, because that's just going to be me bent over scrubbing away on things, I do want to tell you guys there's a lot of stuff going on in the news right now, and in particular I've seen one study that has been published and starting to be shared around Facebook and stuff like that, and it's about the fatalities due to coronavirus. And one of them is claiming that 20% of the fatalities are happening in what is their term? Young adults. I don't know whether any of you have seen this. It's being shared all over Facebook. It's being spread all over the place. But it's something to watch out for. I think we're going to see a lot of this. And whenever you see something that numerically is starting to give you a message like this, think about it like a scientist. What is your data? What are your numbers? Because if you actually go in and read the article, which I did, you're going to find out that they are claiming anyone from the age of 20 to 64 is a young American or a young adult. Sorry, not American, adult. And so, to say that 20% of all the cases are anywhere from 20 to 64, well, yeah, of course they are. That's literally more than 50% of the entire average human lifespan. Yeah. Watch out for values like that. And if you see something that it looks like that doesn't sound right, really, whoa, double check the numbers. Because I guarantee to you, with all of the idiots that are down south right now on spring break, ignoring this entire thing, that a lot of publications are going to try to sensationalize it to try to get through to them, to try to convince them to get the heck off the beaches and to actually do the distancing. All right. So, sorry. I'll get off the soapbox. Actually, no, I'm not. I'm streaming. This is my channel. I can stay on the soapbox as long as I like. And I do love how I look and the sound of my own voice. So it could be a while. All right, number 3. Number 3 was talking about Venus flytraps. And if we take a look at it, it says that we observe 150 that can eat large flies. We know that eating large flies is a recessive trait. And there are 400 that can only eat the small flies. So now what you need to do is you need to take those values, calculate out what your PQs would be. From there, derive your P squared, 2PQ, and Q squared values. And then we compare them to a store that we go into. It only has 56 plants. And hopefully you guys got values somewhere in the neighborhood of P squared at 0.15, 2PQ at 0.48, Q squared at 0.37. Which means, based on that we would expect to find 21 plants that can eat large flies out of 56 plants. do the chi-square analysis on that, what did your numbers end up as? Your numbers were a little bit off? It may well be. Remember, it depends on where you round. And if you're off by just a little bit, don't stress over it. Because, once again, it's rounding, it's significant figures, it's an iffy thing, but you'd still get points just for doing the math and doing the math correctly. My Q squared, I got 0.37. Interesting. Maybe this is an example of me doing the math wrong then. All right. For whatever value you had, put it through your chi-square analysis, and what was your total number? Maybe I wrote it down wrong then. So once you chi-square it, and importantly, once again, what is our critical value that we're looking at based on our degrees of freedom? All right, and if you got 0.64, you are way below the 3.84. 1.14, still below 3.84. 9.1. Okay, 9.1 would be a value over 3.84. So for those of you who got 9.1, you would be rejecting the null hypothesis and you would be claiming there is something else going on that's created this population. For those of you with the value below, you would be saying, nope, this is fine. It's in line statistically with what we expect. All right, I'll need to redo that one. My value was right around 1.2, which we've already covered may not be right. Oops, Matthews and math. We're going to have to test number 5. Ooh, this should be interesting. Maybe I screwed this whole thing up too. All right, number 4 is talking about Martian rocks. And basically, it's just claiming, all right, same idea. Works a lot like the Peaches and all the other ones. And basically, what we want to know is, just like the Venus Flytraps, based on the original number, is this 10 and 10 an acceptable value statistically? Now, my total, with a grain of salt, was 0.164 compared to the critical value of 3.84. So I have to accept the null hypothesis because it's within the statistical limits. Did anybody get something wildly different? I rounded at 2 different places for number 4. Yeah, exactly. And depending on how you round, right, it's going to end up, okay, good. So then I only made a mistake with number 3. And from the sound of it, in the group, half of you did too, which is really interesting. I wonder which one it is. All right, let's take a look at number 5, though, because number 5 is a bit more of a beast. So I'm going to move the camera over here and hopefully adjust this. Let me push this one right off the side there. All right. Get a little bit of focus. I don't know if this is the best way to do it. It's just, we'll see how it works. All right. So question number 5 was now talking about, I don't know. I think it was people. Right? Was it people? Yeah, starfish. Right. Okay, so looking at starfish, we're seeing a scenario where in the first generation, all right, this has got to improve. Focus on the marker camera. There we go. All right. So 1 out of 27, which means if you divide 1 by 27, Yeah, six-legged people would be pretty freaky. Still interested in seeing it, though. So your q squared value is going to end up being 0.04, which means that your q value is going to be 0.2, which means your p value is going to equal 0.8. Hopefully people got to this point. All right. So, with those values, then we come back a couple of years later and we see that the population has changed. And when we take a look at it again, we see that there are 4 out of 31 starfish that are six-legged now. All right, so now taking a look at that, we have to calculate out these values again in order to kind of find out what are we looking at and what should it be. So it's asking, are the genotype frequencies the same as 2 years earlier? Well, we can calculate that just by taking our p squared, our q squared values, and multiplying them by 31 to see if we get the same numbers. Or you can take the 4 and go through these same steps all over again, which isn't necessarily the worst thing. Q squared is going to, in this case, equal, I think it was 0.13, which means that the Q value is going to be 0.36, and the P value is going to be 0.64. So we can say, no, the frequencies are not the same. Then it wants us to say, all right, since it's no, test using a chi-square. Okay, well, we can test using chi-square. Using the previous values that we have from here, we know what our expected would be because we can figure out what the p squared, the q squared, 2pq is. We can group those together. And ultimately, we set up our chi-square saying that we observed 4, but we expected 1. Now I'm going to warn you that 1 value is going to be a rounded value because ultimately it's not going to come out exactly as a whole number, but since we're talking about whole individuals, we kind of need it to be a whole number. So depending on what you write down there, that may change your results, although it shouldn't change them too much. We're going to put that over our expected of 1. And then if we know that we saw 4 out of 31, we know that 27 of them were 5-armed. Using our previous values, we should have expected 20 of them. Do the values there. This is just based on the previous numbers. Yep. Once you take those, you're going to add those together, and depending once again on how you round or whether or not you do, you're going to get a value. And I did this a couple of different times with a couple of variations, and I had values all the way down from 8.7 all the way up to 11.45, which means that we must then reject the null hypothesis. So something else is happening here. And in fact, the question goes on. And it says, if not, calculate the new allele frequencies, which you can easily do based on the numbers that we have. I'm not going to worry about that. And then in the little brackets, it says, given that the current mutation rate is 0 and there is no natural selection acting on these starfish, what is the random change in allele frequency called? Now that last part is key. All the rest of it really doesn't matter. What is the random change in allele frequency called? That's something we went over right before school took its break, and that is called genetic drift. Any form of random change, that's the key. Random. If it's random change, then it's got to be genetic drift. And then the final bit. 7 years later, you come back to the beach. This time, you can find no starfish with 6 legs. Given the most recent allele frequencies you know, is this what you would expect? And I would argue for this one, you don't even need to do any math. Doesn't matter which allele frequency you use. Your answer is going to be no. You expected to find at least one 6-legged starfish. All right, how did that help? Did people's numbers come out somewhere in the range, or did I show you where you were getting confused so that you could complete the problem? I'm trying to get the glare to not be right in the middle of the math equation. All right, for this one, you have a couple different ways. You can either, if you did it in a text document or something like that, you can just send it. Yep, you can share a Google Doc. If you wrote it down on paper, snap a picture of it, and you can just email that picture to me or share it across a Google Drive. That works too. Anything like that, just to see. All right, so now, there we go. That covers most of our chi-square stuff. Yeah, I'm fine with that. Right now, since this is still really new, we're just looking at evidence that people are doing things and not just completely blowing off the school now that everything's going online. So, starting next week, and definitely for the test, make sure to show your work. All right, now before we split for today, a new video came out that I believe I have already linked in Schoology. Yep. Kurgskatch, I can never pronounce them, put out a coronavirus video. Now, the second half of it is exactly what you guys have already seen, probably 100 times right now about flattening the curve. So feel free not to follow through with the whole thing. But the first half of it is actually going over what the coronavirus does and how it's dangerous to people. And that part is actually really worth watching because it'll help you understand some of the dangers that we're facing from this pandemic. So I've included a link to that. When I see you guys on Monday, we're going to start review for all of genetics. Now, currently the plan is to start and roll it in the same order that we went over it originally, which means doing things like starting with origin of life, then moving on to exactly, the evidence to support it, then natural selection, things like that. Is there anything in particular that you folks want me to go over in more detail, or to do sooner rather than later to make sure that we've got time to address it? And while people are thinking and typing, if you're watching this and you're looking and you're going, wow, Matthews, it looks like your lip is a little bit busted. It will be Thursday. The test will be Thursday. As of right now, that's my plan. Or at least I will assign it on Thursday, and then you can do it Thursday night or Friday. Yeah. What you see right over here, my son decided to jump up this morning when I went in to say good morning to him and headbutt me in the face. So he has made his 9th attempt on me. This one drew blood. He's progressing right where I want him to be. Very proud. Yeah, well, it doesn't surprise me. There's been a lot going on for the last couple of weeks. All right, so Monday, I will have the slideshows for Origin of Life and our evidence of Origin of Life. Remember, that's the experiments. The Miller-Urey experiment. Things like the organic soup model versus panspermia versus our RNA world hypothesis. All of those. I'll have those slideshows up for you on Monday. I'll have some stuff for you guys to look at. We'll go over them, discuss each of them a little bit just so you guys understand the goals. Tuesday, we'll probably go into natural selection, which should be pretty much the easiest by this point. All of you know or have heard natural selection enough. I doubt I'm going to be able to provide something that is super intuitive and suddenly going to give you greater understanding, but we'll give it a shot. And then I'm thinking Wednesday and into Thursday, go over Hardy Weinberg, go over once again the ideas of speciation, our forms of selection, directional, stabilizing, disruptive, forms of isolation, both prezygotic and postzygotic, the things that block the zygotes from meeting, things like geographic, behavioral, and temporal, and then also the things that cancel out the continuation or the creation of a species if the zygote is formed. Things like our hybrid infertility, hybrid degeneration, things like that. All right, so that's our current plan. Anyone have any questions for right now? All right, I'll stay in chat for a couple minutes in case you all do, but I'm going to turn off the feed. I'll see everybody on Monday. Have a good weekend. Stay safe. Yeah, stay safe.